keynote session is online. And I request our 4 student representatives to take up their positions so that when there is a question answer synthesis and analysis of oligonucleotides has made him a renowned scientist in the field of oligonucleotides drug discovery. He will deliver the Victor McKusick Memorial Lecture and would be joining us online. Thank you.
Okay, thank you very much, Dr. Neeraj Sarkar and the entire ICREST team. So today I'm going to talk a bit about oligonucleotide therapeutics. Basically, this is about 25 years now, and this oligonucleotide therapeutics came along the way to have certain medicines available in the market. So my talk will be somewhat based on this outline. There will be obviously certain introduction, and I will discuss current status of ASO and siRNA therapeutics. These are 2 types of oligonucleotides. Those are currently available in the market as a drug. There are certain drugs with this category of oligonucleotides. Then I will touch upon mechanism of ASO and siRNAs. Then we'll discuss discovery limitations and efforts for finding solutions for them. Research and discovery at my company, what we are doing and what kind of work is being done here. Finally, conclusion and acknowledgements as well. So basically, if you see the oligonucleotides, these are nothing but the DNA and RNA molecules. And DNA and RNA molecules, but they are not like natural DNA or natural RNA molecules, but they are much shorter than that. And usually 20 to 25 nucleotides long. There is always kind of little bit flexibility in this number of nucleotides, like they can be little longer or little shorter, but they are termed as nucleotides. And in this category of oligonucleotide strands, we can include single strands, we can include double strands, and at the same time, this very important category nowadays also include functionally similar structures. Those are similar to that of DNAs and RNAs. So this very good field of therapeutics has started evolving ever since the Human Genome Project, gene sequencing. And with the knowledge from gene sequencing, slowly we got to know about various functions of genes and their roles in a more better way than ever. And it gave rise to several fields of oligonucleotide therapeutics. And the prominent being listed here, the antisense oligonucleotides, that's what I call ASO, small interfering RNAs, clustered regulatory interface or palindromic repeat, what is currently known as CRISPR, microRNA, mRNA, non-coding RNA, small variant single guide RNAs, and even there are certain oligonucleotides that are called immunostimulatory oligonucleotides and ophthalmosal. And there are more coming on. There are several different terminologies being developed every passing year, and we will be seeing more type of oligonucleotide therapeutics coming in coming years. So we are mainly focusing on the 2 categories during my entire talk, anti-oligonucleotide and the small interfering RNAs or siRNAs. The reason being because these fields so far have overcome so many issues, and we have several drugs in these categories. So first drug that belongs to ASO category, what we have said, was approved in 1998, senescent. This is primary trophy indication, and then it targets MN2 gene. Inortelceptin, this is Rankin, and it is useful on the human pituitary transpacific, that is TTR microthesis, and TTR MR. So if we see all of them, they are useful for certain indication, and they attack the target, the RNA. And this is the beauty of the oligonucleotide, that they go to the genetic level, and at genetic level, they work on certain targets, and especially the messenger RNA, and they interfere with the protein synthesis, and then they either correct it, or they just interfere with the protein synthesis to stop the protein synthesis or the production of protein inside the body. A certain protein. And this highlighted one, that is with number 51, 53, 45. These are these are the ASO drugs. I highlighted them particularly because I got an opportunity to work on these drugs for their stability testing. Work on their stability testing, and I'm really fortunate to do that, because those were the earlier days of development of these ASO drugs. I did not work on their development. I worked on their testing after they have developed. And there are these other drug candidates. The last one is basically not ASO, but it is APTA. I included that in the category of ASO just because its mode of action is somewhat closer to that of oligonucleotides. So these are 11 drugs. Those I have categorized as oligonucleotides. If we see the siRNA, basically they work as interference to RNA. Those are 5 drugs, and all 5 drugs are currently approved, and they are in the market. And they also have specific indications where they are used. And they again target messenger RNA and selectively inhibit other basic proteins. And if we see current and overall scenario, apart from these approved 16 drugs, there are over 80 oligonucleotide and siRNA drug candidates. Those are in the pipeline, and they are at least at clinical phase. This is the data from all over. It's not US or Asia, but it is from all across the world. 8 oligonucleotide drugs, 30 ASOs and siRNAs are clinical. And there are hundreds of oligonucleotides. They are under study globally. And most importantly, because the success of ASOs and siRNAs, the investment in this field in recent years is increasing, and that has already reached to the multi-billion US dollar. So let's discuss the mechanism of ASO as well as the siRNA. A few things we need to consider when we study the mechanism of ASO and siRNA transcription inside the body. They are big protein synthesis. Then the target messenger RNA. All of them target messenger RNA with messenger RNA gradation or messenger RNA correction. Those are 2 end results. Those are possible by the action of ASO or siRNA. And action starts with transcription or transcription means before messenger RNA forms or after messenger RNA forms. But it is always before translation. That means it is always before the synthesis of protein. And there are certain established production of ASOs and siRNA. And if we see the RNA interference, we can siRNA, how siRNA works. So this picture shows very systematic action of the siRNA. So after we inject siRNA in the body, it forms the siRNA carrier complex with certain peptides or proteins inside the body use of maybe some even enzyme starts working immediately. And then they fuse into the cell. It go inside the cell. It's not outside the cell. What action is happening? That is all inside the cell. And they enter the cell in the form of endosome. And this endosome needs to release the RNA before it starts working on certain messenger RNA. And siRNAs are complex. They are there with the complementary sequences, two sequences. One is called antisense sequence, and another is called the sense sequence. Sense sequence is specifically based on carrier of antisense, and this siRNA after endosome release, like the cell, forms the complex with risk factor, and this risk factor complex along with siRNA plays a very critical role of binding of nucleus and turning antisense structure into the active ingredient for the next stage. And this antisense that is released from the sense tract from nucleus along with the risk factor goes and binds mRNA, messenger RNA. And after it binds to the messenger RNA, that particular part of messenger RNA is not available for protein synthesis. And over the time, that messenger RNA gets cleaved and the fragmentation occurs, or even sometimes we can say the degradation of that messenger RNA happens, leading to the blockage of transcription. The entire transcription process gets blocked because of the cleavage of this messenger RNA, and therefore the protein synthesis or specific protein stability gets overcome, and by that way, any protein or excessive synthesis of protein leads to certain conditions. Gets cured, and this mechanism is used for RNA interference, including or non-similar. They do the similar. Next is RNase H cleavage and steric hindrance. This is somewhat different. This is particularly different from the RNA interference. So RNase H cleavage and steric hindrance, they work somewhat on this similar mechanism. What happens is after transcription we get messenger RNA, and after we get the RNA, this RNase H cleavage and steric hindrance occurs with the ASO. So ASO is antisense nucleotide. This is single strand. So we are using two different oligonucleotides, that is the siRNA, antisense oligonucleotide. So antisense oligonucleotides are essentially single strand oligonucleotides, like the siRNA. They are injected into the as a single shorter oligonucleotide, and they are more closer to that of DNA, not to that of RNA. The siRNAs are very much RNAs or closer to RNAs, but the ASOs are closer to DNAs. And after they enter into the cell, usually they enter inside before messenger RNA comes out the nucleus in the cytoplasm. They enter into the nucleus and they bind to messenger RNA. After the ASO binds to the messenger RNA, it either deploys RNase H ASO keeps binding that messenger RNA tightly for certain time, automatically certain translational arrest process, that messenger RNA does not survive inside the cell for longer time, and then it gets degraded, leaving the ASO. And then it has to again pairs with the stimulus keeps on its work until that particular picture being transcribed through the processes. And there is splice modulation, mechanism of action we discussed. So splice modulation is mainly happening inside the cell. Protein synthesis. There is no messenger RNA degradation happens here. That means there is no stoppage of protein synthesis, but it modulates protein synthesis in a certain way so that it gives us better protein. Then there are limitations. Definitely there are limitations on every such research. Oligonucleotides, newer field of medicine. We can say there are certain limitations still exist. Biological limitations cannot be are still being investigated for this purpose. Stability is another issue. There is always a problem with stability or external RNA or external DNA because there are nucleases act on these external DNAs and RNAs and different. So that is specificity. This is related somewhat to the targeted delivery, but it is not necessary that even if we deliver the oligonucleotides to the targeted tissue, they will specifically attach to certain messenger RNA. They might off target, and that possibility makes these efforts. There are certain side effects and human responses also. Those are seen in the use of these oligonucleotides. There are chemistry side limitations also there, like design of oligonucleotide, straight target problem. Oligonucleotides through the synthesis, whether we will be able to get these oligosynthesized in the lab or not, that's also a problem. Limitations of conjugation chemistry are there because conjugation chemistry specifically uses oligonucleotides along with certain chemical entities and try to attach them to non-catalytic chemistry. So usually we cannot use the catalyst or something like that for with this chemistry, and this limits our chemistry application when we do conjugation of oligonucleotides. There are solutions, definitely. We have like 16 drugs in the market, so those drugs fairly overcame all these issues, and most of them use certain type of delivery system. GalNAc is one of the most important delivery vehicles currently being used for almost more than 50-60% of siRNA bacteria. And even under the investigation, there are more and more GalNAc related derivatives are used for the delivery purpose. Lipid nanoparticles, this is just like we make kind of capsules of siRNAs or the antisense drugs inside the lipid layer, and they are delivered by that way. Then we have peptide nanoparticles. It's not necessary modification, chemical modifications of oligonucleotides. If we see carefully the structure, chemical structures of oligonucleotides, to this side, you can see natural DNA and RNAs are there. But these RNAs and DNA, if we put naturally inside body, they don't survive for long, right? And RNAs the nucleate is like on them and destroy them quickly. So we need fairly better stability for this reaction, and further these all modifications and more modifications are encapsulated into these molecules so that we'll be able to use them for the purpose of oligonucleotide drug. So this is phosphorothioate, sulfur is there instead of oxygen. Here, this 2' position of the sugar moiety is changed to duro. Omethyle methoxyethyl. Then there is O-methoxymethyl group in there, with 2' position. Then 2' and 4' position is attached by certain bridge. And then there is another category which completely changes the backbone to the PL. That is called phosphorothioate olivopose. So most of the ASOs currently in the market use this PMO type of structure. Selectivity and specificity mainly is addressed by the screening of several. I will take 5 minutes and will conclude. Thank you, Dr. Sarkar. So this is the genomics where I work, and it's founded in 2011, and so many things here, several patents and everything are present in USA, China, and Hong Kong. In-house research goes just like other R&D oligonucleotide firms, and our delivery platforms, mainly PNP, that is peptide nanoparticles, RNA delivery, peptide docking vehicle, and then we also use lipid nanoparticles. And these are the drugs in pipeline. So mainly, this is the first slide, mainly related to oncology, cancer-related drugs. These are fibrosis, medical aesthetic, antiviral drugs also there in pipeline, and they are all based on the oligonucleotides and mainly the siRNAs. And this is DARPA, and it is used for different conditions or different indications. The conclusion I want to say that this specific area of drug discovery is really, really promising. Despite several restrictions, oligonucleotides recently have proved themselves as very excellent
way back in 2000, how the director IIT Kharagpur had wanted to change this thing. So every one of you sitting in this hall will have to use digital technology. It's like, I think that's the future. So you need to understand how your terrain is. Be it PMLT, be it hospital administration or anybody who is there in this hall. You need to understand the basics of the digital mission. So how many of you are aware of Ayushman Bharat digital mission? Please raise your hands. Ayushman Bharat digital mission. Okay, since it's a long call, I could not do this engaging conversation. I think I could only see one person raising the hand. 2%, 3, 4. I don't see anybody in the back. So there is 5. So the reason I asked you this question is, you as a citizen is supposed to have an ABHA ID, Ayushman Bharat Health Account ID, which means, see, this is something which I keep telling people. We all talk about healthcare, we talk about everything. You as a citizen, it's supposed to have an ABHA ID, and many of us do not even have it. Can you change it? So you are supposed to have an ID. So why is it that we have a conference and we do not have people having an ABHA account? The second question is, of all the 5 people who raised hand, how many of you have an ABHA account? So that is the reason see, this is the Ayushman Bharat mission we will talk about. So the reason, when we started digitalizing the records, so we had this thing, we had a lot of deliberation. In fact, if you go to my, I think Dr. Niloy Sarkar follows my LinkedIn. When we started this journey somewhere in October of 2021, that is when it was actually launched, September of 2021, 23rd September 2021. We do not have what the basics of how do you go about, because I've been in IT for a long time, we have been seeing a digital transformation for a long time, but we did not know how to go about doing the digital transformation in healthcare. Should we do the records which were there in the past, or should we only worry about the records in the future, or you started from the present? These are questions which we were asking. So when we started doing it, we decided that we will take up all the facilities in Andhra Pradesh and digitalize the records. This is something which is interesting. If you see the last 3 words, I remember, I don't know Professor Arun Singh is sitting here or not. Yeah, he is here. He would be more than happy to see these last 3 words of the digital mission. The reason being, I did not know it. For me, I am an administrator. I just do things which government tells us to do. The reason, one of the reasons we do not publish a lot of medical research is the records are not available. If I go to a doctor and ask him, do you see a trend of cardiac arrest happening in India post-COVID? I think most of you must be aware that post-COVID there's a lot of cardiac arrest happening or heart attacks are happening. He will say, yes sir, because I see a lot of OB patients. But there is no conclusive record to tell us that it has happened because we do not have records. So these 3 words, the reason being it's not just your record, it also will help the country. And one of the other things which we also know is, I think he probably mentioned in his opening speech, most of the protocols which we use, the medical protocols which we use, it's all Western based. We do not even know whether it will work in India or not. The only field, as far as I know, is HIV/AIDS. There is a Professor Kumarasamy in Chennai who has built a very strong medical records. And he tells that CDC of USA that this will not work, this will work. So that's one particular person. So we can think of many emerging scientists, I think research scientists which should emerge just by doing digital records. So these are the things which we think we should do. This is the entire gamut of things. In fact, if you see the older, the way we respond to epidemiological threat, we suddenly see a dysentery, suddenly a van of people will go there to the village and they'll start responding. What we can have is, instead of van going, we can have a dashboard which can do that. So this was the vision from the day one. We'll have a command control room which will do it. So this is our journey. I think I briefly talked about it. October we started doing it. We started registering. We also have it's the only state which has 98% of the government doctors on the digital platform. And we also have our hospitals on e-hospital. In fact, the hospital management students should probably have a hands-on usage of it. In fact, it will give you a lot of hands-on, usage, how you will be able to use the system. In fact, I would advise that from day one you should be able to use digital libraries. So this is the record which we have. In fact, we are the largest in the country with 36 million ABBA accounts. I am sure that there are more people. In fact, I would advise even after you going, it takes only 5 minutes to make your ABBA account. Our state is what? 4.5 crore population. We have 36, which just 90 lakh population which doesn't have an ABBA. It is not just, it will help you. It is more like a digital locker. You put your records, it will always be there. It will also show you how the magic which happens over this. So we are also the first state to nursing registry. Because we have been leaders in digital health, so we are also the first state to do it. So you can see, I don't know where is West Bengal, I can't see West Bengal at all. So this is how we look. If you look at the records which we have put in the, so that is the reason we win every single award. You keep a competition, we'll keep winning it for some time. So you can see what is Andhra Pradesh, which is 64% of our, health records. I think probably that's the reason Dr. Sarkar made sure that I come here. So these are important. I don't know how many of you are hospital administration student here. Every single thing as a nodal officer. In fact, what we did is we made the mistake of training a doctor to run all these applications. So you see each module has a specialist involved. Maybe a nurse, maybe a sanitary inspector, maybe a dietitian. So these are things which you should know. So there are 12 different modules on which you need to have an hands-on training. In fact, I would not, because I'm already told that I'm supposed to finish it by another 15-20 minutes. So I'm stopping, but we'll also interact. I think for post this session we'll have a small brief interactive session on hospital administration alone. So this is our, the PSC. 97% of our total PSC is on digital health. 100% of our urban PSC is on digital. This is transformation, which we talked about. If you have ever noticed that map which I showed you, the reason you will also go and work. In fact, the hospital administrator who are there in the hospital, you will go and work in a good institution. For example, when we met Dr. Devi Shetty somewhere in December of last year, 2021, he told us only one thing. Naveen, I could do it in Bangalore hospital, but I could not do the same thing in Shimoga hospital. Whereas in Gurgaon, I don't even have to try much, it could happen. So what you would do is, you think it's easy to work within the organization. In fact, you will also find that even within the organization, there are geographical cultures which you have to adopt. So what you basically become is the change agent. You will be basically a change agent. How do you become a change agent? Can you change first? Can you yourself change first? If you cannot change yourself first, you cannot be a change agent. So that is where you start, thinking and doing things. So the only way you adopt and do things is to, observe a lot of things. Okay, this is the magic which we talked about. None of the states, I don't think any other state has this kind of facilities which we are showing you now. Every lab record details which we do goes to the WhatsApp of that person and through an ABBA ID. Every single data. So you can see the entire sheet which comes and it is saved there. This is what we have done. So we also take a customer feedback. When you do a hospital administration, they are customers for us, right? So we take a feedback from them, saying that whether they were happy with the facilities which we ask. So these are the questions which we ask and we take it from them. We also have a telecaller facility to ask follow-up with them in case if somebody is not happy with the services. So I think when I walked with Professor Das, he mentioned that there's a need to change the way we deliver services in government hospitals. The reason I'm proud when I stand here, in the state of Andhra Pradesh, it is not the private agency which is leading the digital health. It is government of Andhra Pradesh which is leading the initiative in Andhra Pradesh. And our hospital, when I talk to you, I'm talking about 1700 hospitals, which includes my the teaching hospital, area hospital, district hospital, the PSCs, which are on digital platform. When people come and tell you that you can't do things, right? So government does things and show you. And if you look at if you go to the ABDM dashboard, it's governments which is doing the digital change. The reason we wanted others to collaborate, in fact, when you look at ABDM platform, when you are ABDM compliant, it is easy for each one of you to exchange data. You might not be able to carry all your records all the time. I'll show you the second thing. So this particular patient, so this is an access login of a doctor. In fact, the doctor is, so we have pulled the data. Can you believe it? The ABDM was launched, I think she has come, so we have 5 more minutes. So the ABDM was launched somewhere in 2021. Can you see the data which we have pulled is 2018, all the records which we have pulled, which are already in the systems. We also pulled a record of the X-ray. And this was, he had a surgery, and we pulled the record from our insurance data. So there is so much of data which is available. This is an accident which he had in somewhere in 2018. So we were able to pull the record and show it. So we are also working on fax-based system. So this is a scanned data. When you have a fax-based system, you'll be able to even do analysis over it. So that's the best way. In fact, I'm told that yesterday Fujifilm and others also signed an agreement to do a fax-based ABDM complaint system. The next magic is this. This is the thing which I keep talking about it. This is the digital stethoscope, which is integrated with the your ABDM. So your data is directly plugged into your system. The most beautiful, in fact, I think the other. Okay, this is my most, I didn't see this side. This is my most important data, which I love. Places, if you look at, you think you will have doctors everywhere in this country, right? But there are no cardiologists available in many places in this country. People simply die. People simply die. This is what will change the way we stop them from dying. The reason being, I can put a digital ECG machine somewhere in some tribal area or some hilly station. I don't need any doctor. There could be an LT lab technician who is able to put a 12 node or a 3 node or a 1 node, whatever, how many hour nodes we'll put a digital ECG, and that guy will be able to put these records into the system. And our system, AA or ML system, will read all those records, only those records which are supposed to be seen by a cardiologist. We'll go to the cardiologist at the command center. In fact, we are going to use this for our Stenai, project. So this is how the digital healthcare will, revolutionize in the future. So it's the last photo which I wanted to show is, you would see that it's not just the doctors who play an important role. It's even that the digital operator who is sitting at the entrance of your registration. We in fact facilitated some of them. Each one of them have a very critical role to play. So digital healthcare is not about doctors or not just about nurses. It's every single one of us who are part of the system who is trying to do, even the data analyst, who is able to sit there and it will, change. So I conclude this. In fact, when I talk about it, Dr. Professor is also with me. 10 years from now, India will change a lot. For only one reason, we have a lot of records. And this will boom as medical innovation, which we talk about medical innovation. And when the country becomes a medical innovation leader, it will be a success. In fact, the way TCS made money, Infosys made money, each one of you are involved here. I would encourage you to learn more in digital, healthcare. It will start, but 10 years from now, we will see unicorns in medtech. And this is how the country will transform itself being a leader. I think that's the way we'll become transform ourselves into a superpower. Thank you so much for watching.